Birding with, what's up? Okay, cool. So today I'm going to be speaking about birding with Python and machine learning. So yeah, let's just jump into it. A little bit about me. I just finished writing a book called Make Art with Python. It's programming for creative people. It's basically the book that I wish existed when I started programming. And actually, 2 weeks ago, I just started at Datadog as an APM evangelist, who is hiring, by the way, as everybody else. So, birds. Exactly, right? So yeah, let's do some machine learning with birds. So, machine learning. A lot of the times nowadays, it can kind of seem like it's the super high-tech thing. You need supercomputers. You need huge amounts of data. And the hype train is like full speed. You know, neural networks are software 2.0. This is a little bit biased of an opinion. It's from the director of AI at Tesla. But really, there is something new going on. People are building a new kind of software by assembling networks of parameterized functional blocks, okay, and training them from examples. So basically, what that big sentence says is that we're using bland blank functions to train on a data set and making programs that kind of write themselves, kind of. So one example of this is from 1998. It's called LayNet. And it uses something called convolutions. And this was kind of one of the very first practical applications of convolutional neural networks. And these are what's really key for any sort of computer vision using deep learning. So the data set in this case is black and white, grayscale, handwritten digits. And so each one of these digits is labeled with a value from 0 to 9 of what they represent properly. And so the way you train it is first of all, you initialize it with random. So everything has random weights when you start. There's no starting from something. And so you run it through and you make a prediction of what class it is out of the set of classes you have. And then you get an error and then you run back propagation and you update the weights to try and get closer to the correct predictions. And so as I said before, modern machine learning is big data and big computation. It seems really scary. It seems like something only the big, real professionals can do, and not really something, you know, you can just jump into. And so the other day, Google just announced their new TPUs. Each one is 100 petaflops of machine learning hardware acceleration, which is just insane. The bad parts about it, as you know, just somebody who wants to hack around and not somebody who's serious, is that in this case it's not for sale, right? You can only rent it in the cloud. And to rent it from the cloud, it's actually $56,000 a year. So a little bit steep just to kind of get your toes wet. And then, of course, the other problem is you've got to get your data in their cloud. So on the other side of the things, there's NVIDIA, who has been building GPUs to do your own kind of experiments on your own deep learning workstation. And this has really kind of taken off because it gives you an excuse to build a gaming PC, you know, while you say you're doing deep learning research. But there's still one thing. This one's $9,000. This is like, you know, the most recent awesome setup. So besides like the insane computational resources you apparently need, there's also these huge data sets, right? And so ImageNet has over 14 million image URLs. With 20,000 classes. Coco is another data set and it has 2.5 million labeled images. So it's not exactly something you put on a thumb drive and run with. So hackers and hobbyists need not apply to machine learning, right? It's kind of a closed door. You can't go anywhere near there. But not really, because there's something really cool called transfer learning. And so the main idea with transfer learning is that you take somebody else's work and you basically steal it and make it your own. So what you end up doing is you end up freezing all of the layers up to the last layer. And the last layer is where it makes its final class prediction. And you replace it and retrain the classes according to your own personal classes. So you cut off the end of the grown-ups' work, and you make it your own, right? Using OPG, other people's GPUs. So the reason you can do this is because convolutional neural networks are really good at building up transferable things. So these convolutions are really just filters, and they build up looking for patterns. So in here, you're seeing at the very earlier scale, you're seeing looking for diagonal lines, looking for patterns, really. And so it grabs out those patterns. So what is a convolution, really? It seems like a big word, seems mathy. Mathy seems complicated. So it's really just a grid of values that you multiply a pixel and its neighbors by. So convolutions are really about a pixel and its relationship to the surrounding pixels around it. All you're doing is multiply and adding. There's no insane, crazy math you need to know here. So applying a convolution, this is how you do it in NumPy. It's really straightforward. I don't know if you can see, there's a little grid here of the 1, 0, -1. That's the shape, and that creates a vertical edge detector. And you'll see how it transforms the input black and white image and then outputs those vertical lines. So a cool thing about convolutions is they work with rotation. So if you just rotate that list of numbers we had before, you can end up with a horizontal detector. They can also be used to do things like detect edges. So in this case, this just detects all edges between black and white, right? They can also blur. So you can see convolutions are really quite flexible when it comes to manipulating the relationships between pixels. And there are tools out there. This one's called the Deep Visualization Toolbox. It lets you actually look in individual layers and see what's being activated when. And of course, the whole reason we're on TPUs and GPUs is because this sort of stuff is really fast on GPUs. You have a bunch of processors all doing the same work at once instead of 1 or 2 cores working individually. All right. So let's get into computer vision and birds. So this is actually from World War II. They would strap cameras onto pigeons and take overhead photos to get recon. So why birds? You know, birds kind of are everywhere, you know. They're very highly adapted to humans, and they're, they are, come on. Yeah. So they're also highly adapted to humans, so they'll be around you. And if you're looking to do some machine learning training and you want to rapidly iterate, you want something that's close by and easy to train on. So I put this in my backyard. So the thing that really got me excited is that crows in particular are highly intelligent. So this image here is 8-step problem solving that was done by some researchers with a crow. So the crow takes a twig from place 1 on this little piece of rope, and then it goes into 2, 3, and 4 boxes and takes rocks out of them and puts them in the 5, 6, 7 box, and then gets a longer twig and grabs a little piece of meat from box 8. This is a carrion crow. In Japan, they've been known to take nuts and drop them in front of cars to have the cars run them over and crack them open. The insane thing, though, is that they do them in crosswalks, and they wait for the crosswalk to change color before they fly down and eat the nut. And as I said before, you know, the great thing about birds is that they're everywhere, and so there's actually a crow that is in my neighborhood, and I live right there down in Florida. So I really want to build, my goal was to build a robotic platform to explore crow intelligence. There's just one little problem, and that's that I haven't had any crows come to my house. So, yeah, exactly. But I did detect other birds. And the problem of detecting birds is transferable to other species, right? So if we have a platform to detect individual species, we can transfer that to the wild and use it to capture and record videos any animals in the wild. And I think that that's kind of, going forward, something that'll be really useful to people worried about conservation and wildlife. All right, so deep learning cameras. This is a new platform that everybody's still deciding what it is and what it means. We don't really understand the full implications of it just yet. Nobody's really decided what the killer app is for it in general. And so June 14th, Amazon is going to come out with this thing called Deep Lens. And it's going to come with these 4 starter projects: object detection, which takes in an image, tells you what class of objects it is; style transfer, which is kind of this artistic colorization; face detection, of course; and activity recognition. So actually looking at what you're doing if you're playing guitar or something like that. It's got a $250 price point. It's cloud connected, and it's super integrated to AWS products. On the other side of things, there's the Raspberry Pi. And so this is what I actually used to do my first experiments. I just took a Raspberry Pi, hooked it up to a USB camera, and streamed it to my computer where I did inference on my computer. I actually made a GitHub repo that you can go check out and get started right away. It's called Poor Man's Deep Learning Camera. Google just came out with this AIY project. I built it a few weeks ago. It's super cool, kind of tricky to build. I flipped the connectors for the camera module by accident, and so nothing happened. And then backtraced and got it working. But their default demo is a joy detector, which is kind of a interesting guess at what deep learning cameras are going to be. And then finally, there's my personal favorite. NVIDIA has this platform called Jetson. And they have a TX1 and a TX2. The TX2 is just insanely powerful. It's got built-in GPUs. And this is what I use to do my experiments on, mostly because it includes a connection for solid-state drive. And so I would just put all my captured images directly onto the solid-state drive. So deep learning cameras in general. Is it a photographer who knows when to shoot, a platform for detecting objects, for occupancy sensor, shopper tracking? No, it's a platform for birding. So let's do it. All right. So step 1, steal model. And the model I end up stealing is called YOLO, for You Only Look Once. It's from Joseph Redman. And what it does is object detection with localization. So it tells you what's in an image and where it is in that image. And so for my first project, I used tiny YOLO model, and it's trained on something called VOC. So a VOC is another data set that's just a bunch of images with labels for what's in the image and where. And I actually used a port of it to TensorFlow called DarkFlow. And so VOC is actually trained on 20 classes of objects. And you'll see right there, one of the classes of objects is bird. So that's pretty good for us if we want to just steal something and call it our own. And so I'm going to first bootstrap my training data by just detecting birds. And then later on, I'll label those birds and train on that. So step 2 is getting a proof of concept done, right? You want to know if this model is really going to be capable of detecting in the wild. And so that's kind of a real struggle. So for me, I actually couldn't get any birds to my damn house for the first 2 weeks. And I ended up having to put water and multiple feeders out there, and then I finally got way too many birds. So just as a heads up, in case you end up trying any of this. And so, like I said before, I used a Raspberry Pi, and I did inference on the desktop. So there's the USB webcam, there's a web server running Flask, and then there's my desktop computer that's just doing a get and downloading an image and doing TensorFlow detection. So it's super simple, super straightforward. And of course, like I said, you got to wait a few days, but eventually, I got my first bird images. All right, so then step 3, you kind of got to deploy a more robust solution and collect data. So this is all my components in place. I actually ended up building a little wooden enclosure because I wanted an excuse to work with wood. And And yeah, so you'll see I got let me see if this works. Yeah, I got the TX1 right here. I have my external hard drive right here. And I've got my Raspberry Pi and a servo right here, or a stepper motor, sorry. And so the original idea was that whenever something happened, I would do an HTTP request to this Raspberry Pi, and then I could control robotics here, right? And I would be able to do something when I saw a crow specifically, right? I can throw a piece of meat out there when I see a crow specifically, or start the process of giving him a little game to play. And so this is what my final ridiculous camera ended up looking like. So I 3D printed a holder for the Raspberry Pi camera and the webcam that I have hooked up to the TX1. And so for both of these, I just drilled 1-inch holes, and then I made little platforms that I could Velcro my little cameras onto. And so with that, I actually got detection and recording going. And so I started recording videos of birds landing and capturing data to later label and train on. And so this is also on GitHub. It's called Rich Man's Deep Learning Camera. It uses YOLO v2, darknet, same as we said before, and it records 10 seconds before and after detection. So one problem I had is that it would detect the bird once the bird had landed and been there for a while, and I would just get clips of birds flying away. So I ended up doing a pre-buffer of images, and then if I detected, I would write that pre-buffer out to disk. And then the other thing I had is that every day nowadays, I'm getting about an hour of image sequences per day. So I included a cron job that runs, and it turns those image sequences into MP4s with FFmpeg. And then I can go by later and download that entire data set. Oh. So we're bootstrapping more training data in general by doing this process. So this is what my data looks like. I have just random videos of morning pigeons and carrion crows. Uh-oh. What happened? Oh. All right, cool. So one of the big problems I have, though, is these guys. These are mourning doves. And what they have is a little pouch that they fill up with food. And what they'll do is they'll sit in this bowl of food for like half an hour. And they'll just fill up their gullet. And I'll have half an hour of this guy hanging out in my feeder, which isn't cool. So one of the reasons I want to train on specific species levels is to say, you know what, I don't really care about these guys. They're cool, but I don't really want to know what they're doing. And so the way that we do that is we label and augment our new data. So we generate labels using something called, well, you can generate your labels however you want. I'm not going to push anything on you. But I use this, a label IMG project, and it works really well. One thing I want to note right now, though, is you'll see that it has a YOLO mode. If you're following along, don't use that, because that generates a different output for training than what you'll end up using for the rest of what I'm about to show you. And it's really cool. You kind of just, it's got like WASD keys, and you press W and you draw a box, and then you Command S if you're on Mac to save it out, and then you pick which of your classes. So you have to know each of the species you're going to be saving out as. So like I said, you have to have a whole list of classes. So if you get a new species, you got to kind of add it to your list. And data augmentation is adding distortions to your images to make sure it generalizes. So you don't want to just have a bird facing one way, you want to have a bird facing the other way. You want to add different lighting conditions. And that's something you can use a bunch of other tools for. And in general, I think it's good to start with at least 200 labeled images. I wanted to just give you guys a number. It's kind of, you know. So finally, we got all our data. We retrain and redeploy. And this is the set of steps you have to use if you're using the dark flow that I showed before. Set your number of classes, change your number of filters in the layer before last. There'll be instructions in that repo. Set a number of layers you want to retrain, and then just run the trainer. And so this is what the command line looks like. Starts spitting out a bunch of crazy stuff, and you'll get checkpoints, and you'll have little models you can use. And then finally, you end up with a better model. And sometimes, though, you'll still get things you don't expect, like this little cutie who came by and said, hey, just a couple of days ago. All right, so what now? Well, I started this an idiot when it came to birds, and audio data is actually really important for identifying birds. If I was like a legit birder, I would have known, hey, we can't identify a couple birds without the audio data specifically. So I would add that to it. Time of day by species. So like we already have the data once we have this model with species to know when different species are coming. We could add an infrared camera to do detection at night. We could see who's using water versus who's using food. And then based upon the data we already have, what weather and activity are conducive to what species. And then, of course, now that we've got species label, it's time to deploy it into the wild. So the Cornell Lab of Ornithology is insanely good with data and sharing everything they do. They have a data set called the NA Birds data set. It's like 400 species pre-labeled and ready to go for you. So you have no reason to do anything I just told you. Just go get the NA Birds data set and use that. And then Wild Labs. This is kind of new to me. They're an organization who's just dedicated to using technology in general to conserve wildlife. And they're doing a lot of cool open source stuff. And one thing I just want to touch upon is that old data becomes more valuable as new models get created. And one example of that is, all the images you've uploaded through your entire life, there's models to detect your age, your brands, clothing, all that sort of stuff becomes available to see later on. And so that's it. Thank you.
Thank you so much. If you have questions, please meet with the speaker in the hall after this session. Thank you.
Thank you, guys.